Now, good morning. We're going to work off of a handout today. You'll find it, of course, on your classroom work because you have homework questions for this also. Now, remember you have three homeworks that your questions will come from. You have work, power, and today's simple machines. And then you've got the reading, that one chapter that you're going to have some homework, you're going to have test questions come from. You did not have homework questions on it, but you're going to have some questions on the test on that, okay? So you want to look that over, okay? Just to be on the safe side, you want to look that over, okay? All right. Let's talk about simple machines. Let me grab my glasses here so I can see what I'm doing.
Are we doing an experiment today?
No, we're just going to stare at that thing.
Yeah, I just got that set up so we could sit and look at it. I thought it was pretty. It's very Christmassy. Nothing says Christmas like block and tackles pulley system.
Well, I
So,
didn't know if we were doing
it makes it easier to put the star on the tree.
tomorrow.
Yeah, if it's a tall tree. Otherwise, it's a waste of time. Hey, you asked. All right. Simple machine. Simple machines are basic mechanical devices. I got Leo and Brady over here playing.
He keeps taking my binder.
They keep taking each other's binders. So instead of saying, Brady, please don't take my binder, he's just going to kick at him and wiggle all around.
Because Brady lost.
Is that my brother?
Well, here's the thought. Why don't, if you can't behave, why don't you leave my class and quit interrupting it? Just a thought. I'm just saying, if you can't behave, that would be the next alternative. See how it works? It's not hard. It's not hard. Okay? Simple machines are basic mechanical devices for applying a force and doing work. More complex machines are made of a bunch of simple machines. Okay? The lever is made up of a straight ridged object like a board or a bar which pivots on a turning point called a fulcrum. Okay? Levers makes work easier by using leverages which multiplies the force. When you use a lever, you move a small force a longer distance in order to lift a load a short distance. Okay? An example of a lever includes a seesaw. We're talking a true seesaw where you're up and down. Okay, not the glider things that you see on swing sets, but a true seesaw. Okay, a pair of pliers that you can use to untighten or untighten something. A crowbar, which you use to, snap a piece of wood off of a fence, like I use them to take fencing down and stuff like that. And even tweezers that you use to maybe, shape your eyebrows, ladies. Or guys who yank that big long hair off of out of your nose or something. I like to paint pictures as I go. Okay. All right. Now, as you look at the different types here, a wheelbarrow. Okay. But you'll see where the fulcrum will change. Okay. The wheel of a wheelbarrow is actually the fulcrum. Okay. Because that's where it pivots at. You've got your dirt or whatever you're hauling in the barrel, and then you lift up on the two handles, and it pivots up on that wheel. So that wheel becomes the fulcrum. Okay? When you're working a rake, and there's different classes of these. There's 1, 2, and 3. Class 1, Class 2, Class 3 of a lever. Okay? A rake, okay, if you're raking the yard, okay, you're raking, okay, you're picking up, you're putting it back down, you're raking. Where do you think the fulcrum is? Which one is the fulcrum?
The rake? Your arm.
Which arm? You got two arms. Which arm?
That one.
This one. Yeah. It's the one next to the head of the rake, because that's your pivot. This is an effort that you're applying, okay? And this is your pivot. So that's why it becomes a tool, okay? And it is a lever because it's working like that, okay? That's why, okay? Then you see the scoop thing down there. The fulcrum on it is up where the actual scoop will rotate upward, okay? because you've got the resistant, you got the motion, you got the effort, and the fulcrum is in a completely different place. Okay, so it is dependent on where the fulcrum is located as whether or not it's a class 1, class 2, or class 3. But that's another day. Okay, we'll get into that a little later. Okay, I think it was Archimedes that said, "Give me a lever long enough, and I can move the world." Okay, and what he was talking about is if he could actually take a lever and put it up under the earth, and it was long enough, went way out into space, he could actually lift. You could actually lift the world. Okay, that was his point. Okay, obviously that can't happen, but anyway. I will tell you this: if you guys have ever had to change a tire, or if you ever will, they used to, when I was your age, the lug wrench was shaped almost like a cross, and it's had the 4 things that would fit different size lug nuts on the car.
My dad was
Okay,
screaming.
and I'm sorry, I'm talking, but because of that, it had something you could get some leverage. Okay, on both sides you can get it. Well, now they give you this little bitty thing about that long that fits the lug nuts on your car, and you've got absolutely no leverage whatsoever. And those things are put on with an air gun that jacks them things up there about 2,500 pounds worth of pressure, and you're trying to break it loose with something 10 inches long. It's hard to do. So my recommendation to you is get you a pipe when you get your car. First of all, know where your lug wrench is before you have the flat tire. You have to dig for it. But get you a pipe about that long that will slide right up on it. You'll be amazed at how easy it is to crack those things loose. Because of science, a little bit of leverage. It works. It really does.
It's like in the movies when they
Okay.
have like, the pod or someone and then you jump on the other.
Sure. Whatever. Okay. Absolutely. Anyway, but that is science. It works, okay? Somebody in the last class said, "Why don't you just call AAA?" Because I don't have 4 hours wait for another grown man to come change my tire. I mean, come on, people. Learn to change a tire.
Miller, could you
Learn to change a tire. All right, wheel and axis.
Yeah, boy.
Wheel and axis, Braxton. Wheel and axis is another simple machine. It uses a wheel with a rod attached in the middle as an axle to help you lift or move loads, okay? In some cases, this machine works like a lever to multiply force, like a doorknob, one that you actually turn, okay? A fishing reel. You guys that, you fish with a reel, that's wheel and axle, okay? In other cases, it's used to move objects easier, such as with the wheels on a bicycle. Okay, that's a wheel and axis. Your car. Okay, your tires and wheels are connected to an axle, which of course becomes a wheel and axle, and they are turned by the drive shaft, and that's what makes your car go. Okay. All right, your pulley. A pulley is a very simple machine, okay, this type of simple machine, and it's very simple. It uses a wheel with a groove in it and a rope, okay? And the rope fits into the groove, and on one end of the rope, it goes around the load. You hook it to whatever it is you're trying to lift, and then on the other end, you pull on the rope, and it will lift it up. And it actually does help. I mean, it loosens that load. Or lightens that load up, okay? And the pulley helps you to move the load or change direction of the force. Some examples of a pulley includes a crane. Leo and Brady, why don't y'all step outside and kind of collect yourselves there for a minute. Some examples of pulleys includes cranes, flag poles, and window blinds, okay? When multiple pulleys are used together, it's called a block and tackle. Okay, that's when you have 2 to 3 to 4, sometimes even 5. Okay, depending on how heavy the load is you're trying to lift. Another use of the pulley is with a flat wheel and belts. These kinds of pulleys are often in your car. If you ever looked under the hood of your car, you've got wheels. You might have one this size and then a smaller one. You've got belts that goes around it, and they are both connected to something else. And by the power, by running that, it'll make the AC work. It'll help keep the car engine cool. It has the fan belt, and the fan. You got two of those wheels there, and the fan belt goes on it, and that will help the fan to run up next to your radiator. That will help to keep your engine cool, so it doesn't overheat. Yes.
Would a bike be an example?
A bicycle is made up of a number of simple machines. And we'll talk about that in a few minutes, but yeah, absolutely. Yes, Drew.
There was an old car that my grandpa owns, and it had a bottle of cooler in the front, and then a guy who was looking to buy it said, whoops, that's not a good sign, because it meant that either something didn't work or it overheated a lot. So.
It could just mean somebody changed the coolant in it. I mean, but yeah, most times you find that. If you go to buy a used car and he's got a case of oil in the trunk, you look for an oil leak because there's usually a reason for it. You're right. Okay. All right. Now the inclined plane. An inclined plane is a flat surface with one end higher than the other. Think about a ramp. Okay. And this allows for heavy objects to slide up to a higher point rather than be lifted. It's generally easier to slide something than it is to lift it. Okay. And of course, examples of an inclined plane include slides and ramps. Even the slide that you play on is an inclined plane. Okay. Okay. A wedge is two inclined planes put together. Remember the other day when we did that? You get the wedge. A wedge is a simple machine that is used to push an object apart. When you think about an axe or a knife, okay, it actually cuts stuff. It pushes things apart. Okay. And then, of course, you've got the screw, which is a screw is a special kind of inclined plane. It is basically an inclined plane wrapped around a pole. That's what makes a screw. Okay? And it can be used to lift things or to hold things together. Okay? Some examples of a screw is a swivel chair that spins around. Okay? A lid on a jar. Okay? And of course, a screw that you use to put things together and hold things together. Okay. So some fun facts about simple machines. Simple machines were first discovered and described by Greek philosopher Archimedes. The Egyptians likely used the inclined plane to help build the pyramids. Using ramps would have made getting as large stones to the top a whole lot easier. Okay, Galileo was the first to work out a working mathematical theory on how simple machines work. So, if you're concerned about the math, you can blame Galileo. The bicycle, okay? Bicycle makes up nearly every kind of simple machine in order to make a more complex machine. Okay, think about if you got handbrakes. What is that? You've got the lever, okay, that is making the things work. You've got a wheel and axle. You've got a pulley system on the chain, the flywheel and the two flywheels and the chain. That's basically a pulley system, okay? So you got all kinds of little things going on there on that bicycle, okay? The wheel and axle was an important invention in the history of mankind, and it was first used around 5,000 years ago, okay? All right, we're going to break down now and do some experiments, but I'm going to stop this video and let someone start videoing again because we got to get it set up. Okay.